All right, so let me begin here by just running through the solution to the test. I'm going to do version A. So if you got version B, you're going to have to kind of adjust, okay? All of the problems are the same, they're just in a different order. So somewhere on your test is this problem. So the answer for number 1 was Galois, all right? And since you guys have gotten this so universally wrong, I'm going to make you watch a video about it. It's going to hurt you more than me when we watch that video. I'll just say that. Let's see here. No. So C was 4, 7, 10, and 13 for this one. A union B was 1, 2, 3, 4, and 2, 3. So they're all the same questions. They're just in a different order. I'm going through the A solution today. I will post both the solution to A and B in Canvas once I'm back to have some free time. Here, remember, we only keep one copy of each, so that's the same set. Actually, that set, if we're using sets, it is 1, 2, 3, so they're in fact equal. And if they're equal, if they're the same set, then they are equivalent. Dark Brandon stumbled implies Naruto does not eat ramen is in fact P implies not Q, which was B. If you can dance, then you are a friend of mine has antecedent you can dance and consequent friend of mine, so it was B. The negation of the sentence everything is awesome is there does not exist a thing which is not awesome. So let's see here. Whole numbers between 8 and 14, those are 9, 11, and 13, right? Because I said odd whole numbers, right? So just the odd ones. So there are 3 of those, and so 2 to the 3 is 8. That's the number of subsets there. As you recall, one of you kindly pointed out that my robot butler problem was broken, so we changed the options to 12, 11, and 9 during class. Most of you heard it, one of you didn't, and it cost like 20 minutes of your time. My apology to that person. But when I talk about a correction to a problem in class, you've got to pay attention, because otherwise you're wasting an inordinate amount of your time. Okay, so hopefully that will not happen again, right? The next test will have no typos, right? Mm-hmm. All right. Hopefully. Well, anyway, it's much less likely the next test has typos because this material is just, I really need somebody to check it, and I don't have anybody. Ordinarily, I let my wife read my test after I've written it, but she's out of town at the moment, so, which is also the reason that you got your test back today. I don't know if I would actually be able to grade the test in here between Tuesday and Thursday in a typical week. It's all consuming. There are no grad students in math here, you know that, right? Anyway, so here the answer was C because 2 to the 9th is 512, so that's how many, you need 9 upgrade options to get 512. P or not P is a tautology because it's always true. If you have P and Q statements, P implies Q is logically equivalent to the, what was this called? It was called the, oh, it had some fancy name in your book, disjunctive form or something. Negative disjunctive, I can't remember the exact logician's name for this thing, but not P or Q is equivalent to P implies Q, as this truth table shows. So A was the answer there. This is not the contrapositive, as some of you noticed, right? So if the contrapositive is equivalent, that would be another thing I could have put here, but I didn't, right? So cardinalities of the whole numbers, the natural numbers, and the integers, and the real numbers are equal. Now, the real numbers messes this up, because the real numbers have cardinality of the continuum, whereas these guys have aleph not. So they're not equal. It's false. 2 equals 3 implies all students in Math 115 earn an A. Is a true sentence. It is a true sentence because here the antecedent is false and the conditional. If the antecedent is false, the conditional is automatically true. The only way to make a conditional statement false is for the antecedent to be true and yet the consequent to be false, right? So that is in fact, yes, a true sentence. So for version A people, you had this problem on this page. I forget which one you had in version B. Which one do you have in version B on this page? The what? Oh, it's the not P or Q problem? Yeah. Okay. Anyway, so the complement of A is in fact 0, 1, 3, 5, 7, 8. So yeah, you guys need to work on the Venn diagrams. I don't know, like I mean, there are people. Okay, so let me say this. I think there's improvement in the class on the problem of Venn diagrams. Like if I look at the quiz versus the test, I definitely think more of you are getting closer to the truth for the Venn diagram with the test versus the quiz, which of course is part of the reason I give the quiz, right? But others of you will improve when you see these again on the final, right? So when these are on the final, you're going to shade the right part, right? I believe it. In my heart, you're going to learn this by the final. But a lot of you are some of you are really, really far off here. Like, I think if it's one of the interesting things about large lecture section is you get all possible wrong answers. You know, like I have someone who's shaded everything except for this. I have someone else who's like, I can't even remember, just so many wrong things. So what I tried to do in the grading is I just shaded in the part which was right so that you could see why you're wrong. Either something's missing or something's covered that wasn't supposed to be covered, you know. Any questions before I go on to the other ones? So one of you had a question. Did I answer it inadvertently in talking about these or no? No? You talk to me after class? In the back? Is that a yes? Okay. I should make you guys wear name tags. Actually, name tags won't do it. You should have a giant hat that has your like name in like a large font that I could see. That's what I would need. So this one is this guy. So A intersect B is the this part, right? And then union with C, so you get all of C. Number 4 in this one. So the intersection has 13 because you're given that the part that's outside of A but inside both B and C is here. That's 6, right? You know that the triple intersection is 7. That's given. So this and this together give us 13 in the intersection. And then I use the inclusion-exclusion principle to get the other piece here. So number of B plus the number of C minus the number of B intersect C is this, which works out to 48. I think about, I'm not sure the exact statistics, but like a lot of people did get this problem right. And at least probably an equal number of people got it wrong. Maybe it's like 50-50. I'm not sure exactly, but a lot of people had something that was like kind of, sort of, something, but I'm not sure what it was. But a lot of people managed to get 61 here somehow. I'm not sure how you get 60. Oh, you just subtracted 13. Just subtracted 13. But anyway, understanding why mistakes were made is not one of my gifts. There's some people who have a gift for understanding wrong thinking. Not one of my gifts usually. Let's see here. This one. So here you've got, and again, I meant to cross out that and put an or. We talked about that in class. But anyway, the answer here was 85 because it's, again, the inclusion-exclusion principle. Number of math plus number of chemistry minus the number of double majors here was 85. So I circled the ones that were wrong in your on the truth tables. So everybody, you guys have the same truth tables, they're just in a different order. But So like this one was false, true, true in that top row, and then false, false, true in the bottom row. That makes everything true, which is a tautology, right? Now, if you just said it's a true statement, well, that doesn't quite get it. I mean, that's in the right spirit of things, so I took off a point. If you said something like, this is a self-contradiction, or this is a paradox, or this is a Pokemon, I took off 2 points. Although no one said Pokemon. Sometimes when I'm reading the Bible, I just insert the word Pokemon somewhere to see if my children notice. My oldest son always hits me when I do it. It's just getting hurtful because he's 14 and it hurts, you know? Ouch. This one here, we had true, false, false, true, false, false. So they're all false. That makes this a self-contradiction. Yeah. This one here is where the unfortunate incident happened. I accidentally put an F here where I was supposed to put a T, and a T here where I was supposed to put an F. I tried my best to correct that for you during the test. That said, the ones you were supposed to fill in was false, true, true, false, true, and this is false, true, 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 right? And so when you compare this column and that column, you see you have the same outputs, right? So one of the things that was discussed was that if we have a truth table and we have 2 matching columns, that means that the sentences are equivalent, right? Because they take all the same truth values. So we can show that not P or not Q is equivalent to not P, not of P and Q, like here, right? And what is that? Well, that is, in fact, De Morgan's law, right? Variety of interesting wrong answers here. Like I had some people put Morgan's law. I get full credit for that. Like I mean, I feel your pain. When I'm taking a class in literature or something, I don't remember names either, or whatever. You know, so if you didn't have the D but you had the Morgan, I give you credit. Yeah.
So why do you like go over not P or not Q and then not P? Oh wait, maybe it's wrong. Oh wait.
Let me point at it.
Yeah.
I got a laser here somewhere. Ah, where'd it go?
Like I think the negate outside of the parentheses.
This right here?
Yeah, like that confused.
That means you have to negate this.
Okay.
So which is this one? So true goes to false, false goes to true, false goes to true, false goes to true. Yeah.
Oh, okay. Thank you.
Uh-huh. I do think you guys as a class are closer to being right on center with the truth tables than the Venn diagrams. Like the Venn diagrams, you guys are a little bit further from correct as a class. I mean, there are people in here who have there's someone in here who got every problem right. I mean, I don't know if everybody got, was there somebody who got absolutely every problem right? Close to that, but not quite, but close. Few people. So anyway, there's that. Let's see. Oh, that's it. So any questions? Yep.
So the solution that we changed a little bit, which was about like the robot with
the robot butler.
upgrades.
Yeah.
Yeah, I'm pretty sure it was said that I was just for version A, and so I thought that was just for version A, and so in my test, I guess I still have the original answers. I didn't change the answers, and so I put down 10, which would be the minimum number of.
We can talk about it after class, but
Okay.
It's fine. But come talk to me about that after class. Yep. So I did try to write on the board version A and version B, but I understand it's not optimal. Whenever I do write something on the board, if you don't hear what I said exactly, just take a minute, come up, talk to me, so that you don't take the test without understanding, right? I am here for your questions. That is one of the advantages of this class over the online class, right? You can talk to the professor during the test. Although I guess you can talk to Chegg during your test online. But anyway, all right. Where was I? So if I'll post this online for you guys, of course. Let me put this away for the moment. Let us talk about oh, I shouldn't have put that away. I wanted to show you some things on that actually, but oh well. I'll get my computer back out when it's time. Lecture 8. Let me zoom out a bit here. Huh. Come on. Well. Well, I guess that'll work. So we are in, that's what, chapter what? 11. Yeah, chapter 11. So this is section, section 11.1 and 11.2, all right? I think what we have to, hey, stop that. What? Just a second, let me try putting this in here. Well, this is fun. All right, well, if it'll work, there we go. So what is simple interest? So I do think this topic is pretty simple. I'm sorry, pun intended. It's not my fault, it's just there. So here's how you go. You got your interest is I, your principal. Really? I mean, I'm not even touching it, right? Your interest is I, your principal is P, your interest rate is R, and T is time. Now, to be careful, right? We do need that the rate and the time have to have the same units, like they have to both be, say, yearly and years. Typically, as far as I've seen in all the homework and all the book examples, the rates are always given annually. All right, so if somebody ever expresses an interest rate in not an annual fashion, they're probably trying to mess with you, right? I don't know, I guess, but anyway, so the rate typically is given in terms of an annual rate, a yearly rate. I should mention that there is this weird financial convention that if you're given the time in T in days, the quote-unquote ordinary method says that you take the number of days and divide by 360 to get the number of years. Now that doesn't make sense to me. In a physics class, this dog would not hunt because like in physics, seriously. In physics, I always divide by 365 because, you know, the number of days in a year, 365. Or maybe 365.25 if you're going to take into account the leap year. So don't use this in physics, but for financial folks, to make the formula easier, I guess a standard practice is to take the number of days, divide by 360 if you're going to calculate simple interest by the so-called ordinary method. All right. Okay, so here's an example. I will not destroy the technology. What was that? Oh, so we're back to that again, huh? Is it like about to like, it's like hulking out on us or something, you know? But, sorry. So here we go. $1,000, your rate of 5. Are you kidding me? I'm going to start just making a video and posting it, and we're going to forget about class. At least my video, at least my camera works. Let's see here. All right. So 5%, so here's one of the things we have to be careful about. When you have 5%, that doesn't mean multiply by 5. We have to divide by 100 to get 0.05, right? So percentages we have to convert to, you know, exact fractions, let's say. So that's 5 over 100, which we like the decimal form, 0.05, you know. T here is 2 years. All right, so I said find the simple interest earned on a two-year deposit. So that's $100, right? Invest $1,000. Yep.
That monitor is in the way.
There you go. I mean, I agree. But let's see here. So let me scooch this up a bit here. At great danger to the stability of the image. All right. So invest $1,000 at 7% simple interest for 40 days. All right. So I'm going to use the ordinary method. Woohoo! So my principal is 1,000. My rate is 0.07. Remember, divide by 100. My time, in terms of ordinary method, 40 over 360, which is approximately 0.111. I kept an extra 1. I mean, you need to keep enough. So here's the rule. We're going to round to the nearest cent. Like all of the homework asks you to round to the nearest cent. Some of the formulas you'll get will give you more than a cent, right? This one, like if you use 0.1, I mean, technically it's 0.111111111 and forever and ever, right? But if I just keep the 3 ones, then I get 7.777. And so we round up. So just generally round the figure, right? So since since the last digit, the tenths of the penny are above 5, or 5 or above, we round up. So 7 rounds up to 8. So $7.78 is the interest earned. All right. Any questions? Yep.
Why is it not 365 and 360?
Because this is the ordinary method.
So if referring to days, we should use 360 in future reference?
If it says to calculate the interest, calculate the simple interest using the ordinary method, then you have to divide by 360 if you're given the number of days. I think I actually specifically avoided giving you any homework problems on this because I think it's silly. I think all your homework problems have months, which dodges the question. So, all right, here's one. All right, come on. I'll get it eventually here. So example 3. Suppose you got $8,000 invested at 8% simple interest for a year. So how do we calculate this here? The interest, right? So it's PRT. What is my R? What's my P? My P here is 8,000, right? What's my R? 0.08. And what's my T? 1, right? 1. So I mean, it's kind of silly to even write it down, but there it is. So I get out my handy dandy calculator. 0.08 times, I mean, some of you probably could do this without a calculator. You get yourself $640. Now, is that the amount that you have? No, this is the amount of interest earned, right? So we'll talk about the maturity value or the amount here in a moment. I'll do the next example. You got $9,070 invested at 6.5% for 4 months, right? Find the interest earned. All right, I will not be distracted by the technology. I will not be distracted by the technology. So what's the T here? So yeah, 4 months, right? And so what you do is you take that and you multiply it by what? 1 year divided by 12 months. The months cancel, and what do you get? Yeah, 4 divided by 12 years, aka 1/3 of a year, right? So I'm just writing the units out here to tell you what's going on. I've been omitting the units in the formula down here, and I'll continue to do that. But if we omit the units, we have to do so with the understanding that we're going to make our units match, right? So don't try omitting the units in your physics course. That might go bad for you. You're like, I'm not taking a physics course. Oh, okay, well, good for you. Let's see here. What am I saying? Not good for you. Physics is interesting. You should take physics. All right, so we need to calculate that. So I take my handy dandy calculator, 970 times 0.065 divided by 3. My calculator gives me 11,791 divided by 60, which is of no use. I switch over to decimal form. I press another button, and I lost the number. Let's see here. Nope, I got it back. 196.51666. All right. So we round, and what do we get? What's the answer? 5 what? 52, right. $196.52. All right. So if you got months, what do you got to do? You got to divide by 12 to get the number of years, right? 6 months is a half a year, so forth.
Wait, so when you typed in like 1/3 into the calculator, you said you typed it in as a decimal?
Oh, no, I divide by 3.
Oh, okay.
If I'm going to multiply, I mean, I just, what I actually do is I multiply this times this, and then I divide it by 3.
Oh, okay.
Yeah. But if you were going to multiply it as a decimal, you should multiply by like 0.3333. Like keep like 4 3s at least to be safe, to not have a rounding error. So far, I've had like one person ask me a question about homework in email, and they were like confused about something, and then it was a rounding error for them. So if you have trouble with the homework, think about rounding. It could be it. All right, so next up. Come on. Maturity value, or future value, we take the principal plus the interest, all right, for simple interest. Now, so how's that work? Pretty simple, right? So we invest $3,000 at 9.4% simple interest for 3 months. What's the maturity value? So I'm going to use the P times 1 plus RT formula, right? So see, all I did there was factor out the P, right? The algebra. Did you guys see the algebra there? It's not terribly profound. We factor a P out, we get this formula. But it is the same as principal plus interest, right? So anyway, the principal here is $3,000. The number 1 is the number 1. What's the rate? 0.094, right? And what's T?
3 divided by 12.
Yeah, T is equal to 3 divided by 12 years. Also known as 1/4, so that's 0.25. Now, so it kind of depends what kind of calculator you have, but I would advise calculating this number first, so I'm going to do that. 1 plus 0.25 times 0.094, I get 1.00235. All right, then if I multiply that by 3,000, I get 3,070.5, right? So that tells me the answer is what? $3,070.50 in our usual monetary format, right? You'd think I did something to this, but I didn't do anything to it. I mean, anyway. Uh-oh, sorry. I'll go back. I sense a disturbance in the force. Let's see here. I'll give you guys a second.
That's good, thanks.
Okay. I will scan these and post these, so. Come on. You can do it. There we go. Example 5. You deposit $2,700. After 8 months with simple interest, you earn $81. What's the interest rate? Ooh, this one requires algebra. Oh no. Let's figure it out. So the interest is equal to PRT, right? So what's the interest? The interest is 81. What's the principal? 2,700, right? What's the rate? We don't know the rate, so we put an R there, right? What's the time? Yeah, 8 divided by 12. So we have 8 months, 8 divided by 12 years, right? We could simplify that. That's what? 2/3 of a year. If you don't simplify it, you can still do the math. It's not the end of the world. So 2/3. All right, so what do we get here? Let's calculate that. What's 2/3 times 2,700? That's 1,800 R. So R is equal to 81 divided by 1,800. Right? So there's not a big math prerequisite for this class, but you do need to be able to solve some simple algebra problems like this. This is kind of about as bad as it gets in here, I think. Anyway, I will make a point of making sure to do each kind of problem in your homework in class if all goes as planned. That is my intention today, for example, if this thing will work. So the rate is 0.045. So what do we say? Now your book has a little box with a percentage on this problem. So what's the percentage? 4.5%, right? So if you want to get the percentage, you multiply by 100. So 4.5. 4.5% is 0.045 R. Any questions? Comments? Wait a minute, no comments. I better not allow for comments. That would be crazy. Suppose you deposit $1,250 at 10.4% simple interest. Find the interest earned after 6 months. Can we do this? This one's pretty easy. We do I equals what? 1,250 times what? So that's my P. What's my R? 0.104 is the R, right? What's my T? We got 6 months, right? So what's the time in years? 6 months is what? A half a year? So 6 divided by 12 is 0.5. So the time is 0.5. The rate is 0.104. The principal was $1,250. So what's my interest earned? I get $65. So this is a two-part question, right? I asked what? I asked what's the interest and also what's the amount, right? Find the future amount. So what is the future amount here? It's the principal plus the interest, right? Which in this case is $1,250 plus 65. So we get what? $1,315. So that's the interest, that's the future amount. All right. So you guys help me out here. How about this next one? I think this one's pretty simple, right? I'm sorry, that's horrible. I should stop that. A equals to P times 1 plus RT, right? So the principal is $850. And then we've got 1 plus 0.076. What's the t? 4. Yep, we didn't have to divide by 12 this time. What was the difference? Because this time it was given in years, not months, right? So we just multiply by the 4. And let's work it out. So we've got 1 plus 0.076 times 4, which gives me 1.304. And that gives us $1108.4. So $1,108.40 would be the answer here. What's the difference between example 8 and example 7? Do you see the difference? Why did I use the P equals 1 plus RT formula for example 8 but not for example 7? The reason is I was asked for the interest and for the amount, right? So if you want the interest and the amount, the smart thing to do is calculate the interest and then just add it to the principal, like I did in example 7. In example 8, we're just asked for the future amount, so I might as well just calculate it directly. Yeah? Nothing too profound here, but there it is. Another example. Suppose you have a simple interest loan of $66,000 and it costs you $841 of interest during 9 months. What's the interest rate? All right, so this is a find the interest rate problem. So we have the interest is equal to PRT, right? What's T? T is 9 months, right? Divided by 12. So you get 3/4 years, right? 3/4 of a year. And the interest was 841. That was given. The principal was what? It was 66,000. All right, 66,000. The rate we don't know. And so we got 3/4, right? So how would I solve this algebra problem? I'm trying to solve for R. What I'm going to do to make it easy to understand, I'm going to use my calculator to do 66,000 times 3 divided by 4. That gives me 49,500 R. Then I solve for R. R is equal to 841 divided by 49,500. Use my calculator. And I get 0.01689 dot 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 dot. All right. Now I think the instructions say to like round the interest rate to let's say 0.1% or something. So we need to, R is equal to 0.01698 blah 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 times 100%. So R is actually equal to 1.70%. Now I just rounded the percent to the second digit. Well, I gave you the percent in three digits. This is just a choice on my part. Your homework probably has like instructions about rounding. So, does that make sense? All right. Another place people like to charge you interest is on late bills, right? Suppose you have an electric bill, you don't pay it, and then 5 months later you pay it, then might charge you simple interest. They might charge you some more complicated form of interest, like we'll talk about in just a minute. But anyway, if they charged you simple interest of 12% on a $132 electric bill that you paid 5 months late, what would be the amount owed? It would be the amount that you were owing originally, the principal, times 1 plus RT. So what's the amount was what? 132? 1 plus the rate was 0.12. What's the time here? 5 months divided by 12, right? So we do 5 over 12 there. Ooh. So, well, I have a temptation to do the math without using a calculator here, but I'm going to resist that temptation and use my calculator, as that's probably what you should do. 1 plus 0.12 times 5 divided by 12. That gives me 1.05. So what you got? You owe the electric company, when you pay it 5 months late, $138.60. I guess that's not too bad. All right. So that's simple interest. So for the rest of class, we're going to talk about compound interest, all right? So what's compound interest? What's the difference? So let me talk to you about compound interest. Let me just do an example here right quick. Compound interest. Come on. So let's just look at an example of, suppose you're compounding monthly investment. P equals to, let's say, $100. And I'll make it simple at 10%, well, let's say 5% interest. And that was supposed to be interest, let's keep it relatively simple here, 3 months. And so what I'm going to do, I'm not going to use the formula for this example. I'm just going to do it I want to explain to you the mechanics of what we're saying here, rather than just giving you the formula straight. I will give you this formula in just a couple minutes, but so here's the way it works. Compounded monthly means, so at t equals to 1 month, how much money do you get? The amount you have after 1 month would be the principal times 1 plus the rate times the time. Well, what's the time? It's 1/12, right? So the 1 month is 1/12 of a year, right? So this gives us $100 times, 1 plus 0.05 divided by 12, whatever that works out to. 0.05 divided by 12 plus 1, all right, times 100. I'll get straight to the point here. That number works out to $100 and 42 cents, round a penny there. So how about after 2 months? So the amount after 2 months is going to be given by, you invest the amount after the first month, and then you do the 1 plus, 0.05, and then times 1/12 again. So the way the compounding works is the amount of money, it takes the money that you've already earned in interest in the first month, and you get paid interest on the interest in the second month. That's what's going on here. This is the compounding. So that is, 100.42 times that, which is the same number again, isn't it? So if you look at this, 100 divided, excuse me, good grief, 1 plus 0.05 divided by 12 is, let me just point out that this number here, this number right here, is essentially 1.0041, and I'll just keep a few numbers here, 66, and it keeps repeating like that, all right? So that number appears here again. Right, so if I undo the calculation of the past time, what you see you've really got there is 100 times 1.04166 squared, actually.
You missed a zero.
I did? 004?
Well, that's what you wrote. Like the first thing you wrote, it was up there.
Oh, thank you. You're right. I was looking at the wrong one. I was like, I do have 004. Oh, duh. Okay, so that's the formula. You square that times 100. So, so if I do what I just wrote in orange, I won't have a rounding error, right? So I have $100. Excuse me, I have $100 and 84 cents if I round up the exact number here. So there you go. That's the amount of money after 2 months. This is the money after 1 month. How about 3 months? You do A3. Let me scoot up a bit here. Come on, come back to us. Come back. That's right. A times 1 plus 0.05 divided by 12. But that, again, is actually 100. When you work out the math here, that's $100 times 1.004166 cubed, which is $101. What? Really? Oh, yeah, okay. It seemed really wrong to me for a second there. 101.26. So, all right, so like, again, the idea of the compounded interest is each month, each compounding period, you're adding to the principal, right? And then the next compounding period, you start with the principal you've already earned from the past month, and this just keeps compounding. So if you look at how we just calculated, you know, the amount here, it's kind of terrifying if you look at the questions in the homework, because some of the questions in the homework are like, you're investing so much money, it's compounded monthly. How much money do you have to, after 9 years? 9 years, that would be what? 9 times 12? What? How many compounding periods? 9 years monthly. 9 times 12. What is that? 108? So you'd have to do this 108 times? Well, thankfully not, because if you look at this, you don't actually have to go through 108 steps, right? Because if you look at the formula, what's happening is you're first multiplying by the 1.0416, right? The second compounding period, you're multiplying by 0.00416 squared. The third compounding period, 1.04116 cubed, you start to see the pattern, right? And for that reason, we have a nice compound interest formula, which we will use. Here it is. The amount is the principal times 1 plus r over n to the nt. Now we need to pay attention to how this formula is defined. R is the annual interest rate. N is the number of compounding periods per year. Your book has a table to break that down for you, right? Like quarterly is how many compounding periods per year? 4, right? Semi-annually? 2, right? What else? Well, anyway, there's like a little table in the book with all the different flavor options, but here's the problem. You have 26 grand. You're investing it at 7% compounded monthly. How much after 9 years? Let's do it. So the amount is the principal, which is 26,000. All right. Times what? Times 1 plus. So what's the number of compounding periods? It's 9 times what? 9 times 12, right? 108 compounding periods because of the 9 years. So we do 1 plus 0.07 divided by 108 to the nt. So what was nt? T is the number of years, right? So 9. Sorry. For some reason I'm having trouble thinking. Sorry, it just feels wrong to me. I don't think I'm supposed to have that T there. I feel like this should just be 108, at least on the basis of my previous example.
I think they have the NT in the textbook.
But, well, it seems wrong to me. I copied it from the textbook, but maybe I copied the words down near the thing wrong. This is 11.2 we're in, right? So, A is the compound, let's see here. N is the number of compounding periods per year. Oh, I know the problem. N, I have, my bad. Listen, N is not 108. I'm wrong. I have it right here, right? Look, is N 108? No. What I have right here is what? This is actually NT, right? So that's N. Excuse me. This is N. 9 is T, right? So this, what I've written is right. It's just I'm having trouble interpreting it. My bad. So it's very simple. N is 12. T is 9.
Why is N 12?
That's the number of compounding periods per year because it's compounded monthly. Compounded monthly.
12 months.
Yep. So we have 1 plus 0.07. Oh man. 1 plus 0.07 divided by, again, N is what? 12. So I have 1.0058333 to the 108 power. What is it?
What, compounding quarter, it would just be like N would be 4.
Quarterly would be N equals 4.
Okay.
Yeah.
Okay.
So we get $48,728.60. Right. So, let's talk about the calculation here, right? I'm using on this calculator here, right? So, to do this, right, basically I had 1 plus 0.07 divided by 12, right? This gives me this number, 1.05883, right? I'm raising that number, right, to the 108 power here. So you need a calculator that can calculate 108 power. Do you have a calculator that can do that? Because you need one for the next test, right? So the things before, you could use a relatively simple calculator. This, you need a calculator which can calculate powers for you. All right? So anyway, I had another couple of examples to do, but I see we've run out of time, so oh well. Your homework, I think you can figure out from this. There's like one example I didn't cover, but I hope you can figure it out. So anyway, thanks guys. I'll add an example when I post the PDF.